Welcome everybody to Algebra 2, Section 6.3, Add, Subtract, and Multiply Radicals. So our first step is to simplify all the individual radicals. Then we're going to identify radicals with the same index, aka root, so such as square root, third root, fourth root, and the same radicand, which is the inside. And those that have the same index and same radicand can be combined. Very similar to like terms, just like how we could only combine terms that had the same variables with the same exponents. And for those common radicals, we add and subtract the coefficients and keep the common radical or the index and radicand the same. Just like how when we had 2x, if it lets me right here, 2x plus 3x, we call it 5x. We keep x the same. We don't make it x squared, but we add the 2 and the 3. So on number 1 here, we'll look to simplify the square root of 27 on the first part, and then the square root of 12 on the second part. So the square root of 27 is the square root of 9 and the square root of 3. That is then 3 times the square root of 3 times the square root of 3. Sorry, 3 times 3 times the square root of 3, I misspoke, which is 9 square root of 3. Minus 2 times the square root of 4 times the square root of 3 as we simplify the square root of 12, which is 2 times 2 times square root of 3. And eventually becomes 4 square root 3. Now we can notice that these are both square root 3, same root or index of square, second root, and the same radicand of 3. And so we can do the 9 minus 4 and call this 5 square root 3. If they were different, we would have just called this our answer. But because they were the same, we can combine them. Number 2, we'll just do the same thing with 3 different cube roots. So the fact that this is a cube root of 2 here in the middle is a hint that if we're going to be able to combine anything with that they would have to simplify to 2 times the cube, 2 times something else. And so 2 times 27, for example, 27 is a perfect cube. So 3 times the cube root of 27 times the cube root of 2, which is 3 times 3 times the cube root of 2, and 9 times the cube root of 2. This middle term just stays the same, because you can't simplify it. And then our last term is the cube root of negative 8 and the cube root of 2, which is 7 times negative 2 times the cube root of 2. So negative 14 times the cube root of 2. And so now, since all 3 of these have common radicals, the same index with the same radicand inside, we can combine the outsides. 9 minus 2 minus 14. And that gives us negative 7 times the cube root of 2. On to number 3, some fourth roots. So the fact that this is a fourth root of 3, once again, can be a bit of a hint to us, perhaps, that if we can combine them, they'll be something times 3. Now, we might not be able to combine one of these radicals with the others, and so it might not have 3 times a perfect fourth. But the first one is. It's the fourth root of 16 times the fourth root of 3. The fourth root of 16 is 2. I realize in the last step I wrote cube root of 3 instead of fourth root of 3. And so that ends up being 14 times the fourth root of 3. Started to do it again. Our middle term just continues to stay the same here because it didn't need simplified, which is quite lucky for us. One less thing we had to worry about here. The last one we can simplify into the cube root of 8 and the cube root of 9. Notice this is cube root, so it won't be able to combine regardless. 3 times 2 times the cube root of 9, because the cube root of 8 is 9. And this is then 6 times the cube root of 9. And so we can combine these two, because they're both fourth roots of 3. So we get 12 times the fourth root of 3 plus 6 times the cube root of 9. And we just leave that as our answer. Combine what you can, just continue to write what you can't. Moving on to number 4. We have 2 square roots and a cube root, so chances are we'll probably be able to combine these, but we'll see. So square root of 28 is square root of 4, square root of 7. That ends up being 20 times the square root of 7, as square root of 4 is 2. Cube root of negative 56, that is cube root of negative 8, cube root of 7, which is negative 2 times cube root 7. Hope I forgot to write the index on the cube root of 7 earlier. And then minus 4 times the square root of 25 times the square root of 7, which ends up being negative 20 times the square root of 7, because square root of 25 is 5, and 5 times 4 is 20. Now as we combine 20 square root 7 and negative 20 square root 7, because they're both square root 7s, 20 minus 20 is 0, so you don't have any square root 7s left, so you don't write it. You just have negative 2 times the cube root of 7. Moving on to number 5. Now we introduce variables. So I will take a guess that the first one probably simplifies to something times the square root of 2 in order for these to combine, but it's not guaranteed. I'll simplify these individually here, and then I'll put my answer up here to continue. So square root of 98, square root of x to the 4th, and square root of y squared. Square root of 98 is square root of 49 times square root of 2, which is 7 times square root of 2. Square root of x to the 4th is x to the 4th, all 4 over 2. It's the exponent divided by the root or index, which is x squared. Y is y to the power of 2 over 2, which reduces nicely just to 1. And so back up here, this is 7x squared y times the square root of 2 minus 3x squared y times the square root of 2. And now those have the same radical, square root of 2, square root of 2, but they also have the same variables and exponents. If they didn't have the same variables and exponents, you wouldn't be able to combine them. So they have to have the same variables and exponents and the same radicals if they have both. And so we just combine the coefficients and get 4x squared y square root of 2. And that's our answer. On to number 6. 3 different parts, 2 cube roots, and then 2a squared multiplied with that. So I guess really kind of more 2 parts then, I suppose. So cube root of negative 48 to the 7th, so let me separate that into 2 parts. Cube root of negative 40 and the cube root of a to the 7th. Cube root of negative 40, that would be the cube root of negative 8 and the cube root of 5, which is negative 2 times the cube root of 5. And the a would be a to the power of 7 over 3, which is a to the power of 2 1/3. So that'll end up being negative 2a squared times the cube root of 5a to the first. Then I'm going to go and do this one as well. Cube root of 135 is the cube root of 27 times the cube root of 5. And that ends up being, I forgot the cube root, 3. 3 times the cube root of 5. Then we have the cube root of a to the fourth, which is a to the power of 4 over 3, which becomes the mixed number, a to the power of 1 and 1/3. So that, multiplied with 2a squared, so we have 2 times 3, which is 6, it's 3. A squared times a to the first, which would be a to the third, times the cube root of 5a. And hey, look, these are, I thought they were going to be, but they're not actually. Sorry, I thought they were like terms. And I realized this is a power 2, this is a power 3, so they're almost like terms. They're so close. They're both cube root 5a's. They both have a's, but one's power of 2, one's power of 3. So this is actually just our answer. We can't combine them. Moving on to to the next set. Now we're going to multiply. So in order to do this, you're going to multiply the coefficients and then use the product rule, aka you multiply the outside numbers together and you multiply the inside numbers together. So the numbers outside the radical and the numbers inside the radical. And you keep the numbers outside the radical, and you keep the numbers inside the radical, well, inside the radical. And then you simplify the resulting radical. And keep in mind the product rule is the square root of a, or the nth root of a times the nth root of b is the nth root of a times b. And so the square root of 27 times square root of 5, we're going to multiply 27 times 5 and call this the square root of 135. From there, we say, okay, well, can we simplify that? Well, it'd be the square root of 9, square root of 15, which is 3 times square root of 15. And that's our answer. On number 8, you multiply the 3 times the negative 2, the outsides together, and get negative 6. On the inside of the radical, you do 10 times 18 and get 180. And then you just start simplifying this. So negative 6 times the square root of 36 and the square root of 5, which is negative 36, as we do negative 6 times 6, which is the square root of 36, times the square root of 5. On to number 9. Multiply the outsides together. 2 times 5 is 10. Multiply the insides together, you get the cube root. The index stays the same, the type of root. And then 9 times negative 24 is negative 216, which that's a perfect cube. That's quite convenient. So we get 10 times negative 6, which is negative 60. On to number 10. Negative 3 times the 4th root of 64 times the negative 4th root of 8. So you do negative 3 times a negative, essentially 1, giving you just positive 3. And then you have the 4th root of whatever 64 times 8 is, which is 512. That makes sense. That's 8 cubed. Anyway, and so we have 3 times the 4th root, as we look to simplify this, of 256, times the 4th root of 2. The 4th root of 256, if you're curious, is 4, which is why I picked that, times the 4th root of 2. That gives us 12 times the 4th root of 2. Some more practice here. Number 11. Nothing on the outside of the first radical, so 1 times 5 is 5, because we assume there's a 1 there, times the square root of 48x to the 9th. Remember, when we multiply those x's, we add the exponents. And now, as I simplify that, I'm going to go part by part. So square root of 48, square root of x to the 9th. Square root of 48 is square root of 16, square root of 3, which is 4. Square root of 3. Square root of x to the 9th, we're going to do x to the power of 9 over 2, which is the mixed number, x to the power of 4 and 1/2. And so this is 5 times 4, giving us 20. X to the 4th, or whole number for the exponent, times the square root of 3x to the 1st, or 3x. Number 12, multiply the insides of these cube roots together, no outsides. So the cube root of 270 m to the 12th. Do part by part. Cube root of 270, cube root of m to the 12th. Cube root of 270, that's going to be the cube root of 27, and the cube root of 10, which is 3 times the cube root of 10. And cube root of m to the 12th is m to the power of 12 over 3, which is m to the power of 4. So on the outside we have 3m to the 4th. On the inside we just have the cube root of 10. Number 13. Once again, no outside, so we just multiply the insides, and we get the cube root of negative 108, a to the 13th, b to the 6th. I'm going to do part by part. Cube root of negative 108, cube root of a to the 13th, and the cube root of b to the 6th. Cube root of negative 108 is the cube root of negative 27 times the cube root of 4, which ends up being negative 3 times the cube root of 4. The a's give us a to the power of 13 over 3, which is a to the power of 4 and 1/3. And the b's give us b to the power of 6 over 3, which is b to the power of 2. So going back to the original, or the top, on the outside we have negative 3, a to the 4th, b squared. And on the inside of our cube root we have 4a to the 1st. On to example 14 here. Once again, we're going to handle this part by part, or excuse me, we're going to multiply these together. So multiply the outsides, 2 times 7 is 14. Multiply the insides, you get the 4th root of p to the 5th, q to the 11th. And then we're going to handle that part by part. So the 4th root of p to the 5th and the 4th root of q to the 11th. So that'll be p to the power of 5 over 4 and q to the power of 11 over 4. And for P, that's the mixed number 1 1/4. And for Q, that's 2 3/4. And so now putting that back into our final answer, that's 14 PQ squared outside the radical times the 4th root of PQ to the 3rd into the radical. Now we're going to talk about some binomial examples. So what happens when there's multiple terms inside of parentheses? So we are going to distribute here essentially and just repeat the multiplication. So square root of 10 is going to multiply times each of these. So square root of 10 times 5 square root of 10. So we do inside times inside again. So 5 is multiplying times an invisible 1, giving us 5. And then 10 is multiplying times this 5, giving us square root of 50. Minus square root of 10 times 2 square root of 2. So this 2 is on the outside still. And then 10 times 2 on the inside gives us square root of 20. iPad decided to zoom out there. And so now we simplify each of these. And so this first one ends up being 5 times the square root of 25 square root of 2. Second one's 2 square root 4 square root 5. And so the first one is 5 times 5 is 25 once you simplify square root of 25. And the second one is 2 times 2 is 4 once you simplify square root 4. And so you get 25 square root 2 minus 4 square root 5. And you can't simplify these further because they're different radicands. They're both square roots, but one square root 2, one square root 5. Moving on to 16, here we get to FOIL. So we're going to do 8 times 3, 8 times square root of 10, and then negative square root of 10 times 3, and negative square root of 10 times negative square root of 10. And then simplify, combine like terms from there. So 8 times 3 is 24. 8 times negative square root of 10 is just negative 8 square root of 10. Negative square root of 10 times 3 is negative 3 square root of 10. And negative square root of 10 times negative square root of 10 is just negative 10, which means positive 10. Anytime you take a square root times itself, you just get the radicand, or what was inside. Essentially, it would be the square root of 100, which is 10. So now as we combine like terms, 24 and 10 give us 34. And these can combine because they're common radicals, and we get negative 11 square root of 10, which does not simplify. So we're done. They don't always work out that cleanly, but this one sure did. Number 17, we're going to go through the same process here of distributing. 6 times the square root of 6 times the square root of 6 gives us 6 times 6, or 36. So remember, square root of 6 times square root of 6 is 6, and multiply that times this 6. 6 times square root of 6 times square root of 2 is 6 times square root of 12. Negative 6 square root of 2 times square root of 6 is negative 6 square root of 12. And negative 6 square root of 2 times square root of 2, the square root of 2 times square root of 2 would give us normal 2. So that's 2 times 6, which is 12. And it was a negative times a positive. So 36 minus 12 is 24. And I see, oh, I can simplify these square root 12s, but more importantly, I can combine them. And that's actually going to eliminate my need for simplifying those, because it's going to actually eliminate them because they're opposites. It's 6 and negative 6. So I just have 24 here. Moving on to number 18. 4 minus square root 5 quantity squared. Remember, when there's a plus or minus sign inside this parenthesis here, we can't just distribute this exponent to the exponents inside. That doesn't work unless there's exclusively or only multiplication or division inside the parentheses. So what we have to do is instead write this out twice. 4 minus square root 5 times 4 minus square root 5. There's literally 2 of them multiplying together. And now it's the same type of problems we just had on 16 and 17. So 4 times 4 is 16. 4 times negative square root 5 is negative 4 square root 5. Negative square root 5 times 4 is again negative 4 times square root 5. And negative square root 5 times negative square root 5 is positive 5. Combining the 16 and 5 gives me 21. And the two negative 4 square root 5s gives me negative 8 square root 5, which can't simplify. Moving on to number 19. Yes, we can simplify square root of 12k, but before we do, I'm going to focus on multiplying just like we did earlier, when it was just two things multiplying together before we distributed, I should clarify. So let me, and I could do the same thing with k squared, but once again, I'm going to focus on distributing first. So square root of 3k times square root of 12k is square root of 36k squared. Multiply it times negative 2 square root of 15k squared. I get negative 2 square root of 45k cubed. So now this first one is just 6k. Those are both perfect squares, actually. If you want to do those separately out to the side, feel free. But square root of 36 is 6, and square root of k squared would lead you to k to the power of 2 over 2, which is k to the power of 1, minus 2 over, or 2 times, well, let's do this one off to the side since it doesn't work out quite as nicely. Not horrendous, just not quite as nice. So the square root of 45 is the square root of 9, and the square root of 5, which would be 3 square root of 5. And square root of k cubed is k to the power of 3 over 2, which is the power of 1 and 1/2. So it'd be 2 times 3 for outside the radical, which that would make that 6k outside the radical times the square root of 5k. And these are not common radicals at all because the first one doesn't even have a radical. So that's our answer. On to number 20. As we distribute here, square root of x times square root of x is just x. It becomes square root of x squared, which once again is just x. Square root of x times 2 is square root of 2x. Negative 8 times x is square root of negative 8x. And negative 8 times 2 would be the negative square root of 16. So currently no common radicals, so we just seek to simplify what we can. This one can't simplify, this one can, and this one can. So as I seek to simplify the square root of 8x, which I'll do off to the side, square root of 8, which square root of x can't simplify. That is the square root of 4, square root of 2, which is 2 square root of 2. So far that is x plus square root 2x plus 2 times square root 2x, because remember the x is still there. And then let me simplify the square root of 16, which is, oh, silly me, that's just 4. So I can't combine the 4 with anything, but I can combine these. So I'll go ahead and do so. And so I end up getting x minus 4 plus 3 times the square root of 2x. Now, I'm not necessarily going to be a stickler for if you move this negative 4 here or not. If you put the negative 4 instead at the end, like it was originally, that's perfectly fine. I'm not going to be a stickler about that by any means, one way or the other. It could be debated as far as which way somebody would want that, to whether they have radicals at the end or in the middle, because hey, there's a variable there, so maybe you want a variable in the middle. It's for variables to come before numbers, but you know there's a radical, so maybe you want radicals to come at the end versus in the middle. It really is six in one hand, half a dozen in the other, which means they're quite interchangeable because, as you may know, 6 and half a dozen are the exact same thing. So I could just as well write, and many of us probably will, so I'll just write it this way. X plus 3 times squared x, sorry, 3 times squared 2x minus 4, and just keep it in the same order. And either way would have been perfectly fine. On to our last problem for today, number 21, and this is actually really a two-part problem because we're finding the area and the perimeter of the rectangle shown to the left. Well, quick reminder, area and perimeter, let's remember our formulas for this. So area for a rectangle is length times width, and perimeter for a rectangle is you add up all the sides, which is 2 times length plus 2 times the width, essentially. Or it's length plus width plus width. The same thing either way. So let's find these. So it doesn't matter which one you call the length or which one you call the width at the end of the day. So if we find the area here, let's say I just call this the length and this the width. Once again, it's arbitrary, doesn't matter in the slightest. So I do 4 minus the square root of 6 times 7 square root 6 plus square root 3. And I do 4 times 7 square root 6 and I get 28 square root 6. 4 times square root 3 is 4 square root 3. Negative square root 6 times 7 square root 6. Square root 6 times square root 6 is again 6. So 6 times 7 is 42, so it's negative 42. And square root 6 times square root 3 is negative square root 18. Look to simplify these different fractions here. This one can't simplify, this one can't simplify, but this one can. Square root of 18, that one ends up simplifying, as I mentioned. And it ends up becoming the square root of 9 square root of 2, which is 3 square root of 2. And none of these combine. None of them are common radicals. So this big long string just is our answer. Just happens to end that way. And that can happen. That's fine. It's a little awkward, but there's nothing wrong necessarily. It just looks weird. Now onto the perimeter. So this would be 2 times 4 minus square root 6 plus 2 times 7 square root 6 plus 2 square root 3. You could also, once again, just take 4 minus square root 6 plus 4 minus square root 6 plus 7 square root 6 plus 2 square root 3 plus 7 square root 6 plus 2 square root 3. Essentially, add up each side twice. But I will just go ahead and distribute here to write out less things. And I'll get 8 minus 2 square root 6 plus 14 times square root 6 plus 4 square root 3. And here I actually can combine these square root 6's. They're common radicals. And so I'll get 8 plus 12 squared. Oh, I get, silly me. I called that last one up there in the blue 4 square root 6. That was mistaken. That should have been 4 square root 3. But I can combine the 2 square root 6's, not 3 square root 6's. And so I have 8 plus 12 square root 6 plus 4 square root 3. Oh, silly me. I see what I did wrong as well. I made another mistake. Darn. It'd be like that sometimes. So let me go back and rectify my other mistake. So in the very beginning of the problem, I put it 2 square root 3 in the second parenthesis for my width. That would not be 2 square root 3. Instead, that is actually just square root 3. And so then in my light blue at the very end, it's not 4 square root 3. It would rather just be 2 square root 3, because 2 times square root 3 is just 2 square root 3, which means in my red step here, this is just 2 square root 3. And then this is my final answer, because there's no more common radicals or like terms for us to combine. And so thus we found the perimeter, and then we also found the area earlier. And that wraps up section 6.3 of Algebra 2.